Hello everyone, welcome to my class. In today's class, I'm going to cover equation of lines and planes in 3D. So let me start the class right away. First, quick recall. Besides points and vectors, the three-dimensional space is built with a bunch of lines and planes. And we already discussed about points and vectors in our earlier sections. So let me start the equation of a line. Let me start the equation of line in 2D. A line L is determined by a point and a slope. So in point-slope form, the equation of a line is y minus y0 equals to slope is m, times x minus x0. In parametric form, let's set t equals to x minus x0. Then y equals to, take y0 to the right side, so y0 plus m times t. So these are the parametric equations of a line in 2D. Next, let's write in vector form. So let's rearrange these parametric equations, put x and y in one vector and x0 and y0 in another vector, and factor t out from this term and this terms. Then we have t out 1 comma m, this is another vector. Then in the vector form, we write the equation of line as this is the arbitrary vector x equals to, this is the given point position vector, simply x0 vector plus t and vector v. By the way, slope is m, that means m equals to rise over run. That means I can rewrite m equals to m over 1. Then this 1 is our first component, horizontal component of vector, and the vertical component of vector m. So 1m, this gives me the vector. So great. So I hope this makes sense to you. Now let's move on. We can use this form of equations in any higher dimensional space. So now let's talk about the equation of line in 3D. A line is determined in 3D by a point and a parallel vector. That vector is parallel to the given line. So in the diagram here, this is a line. The point is given here. P point is known, whose coordinates are x0, y0, z0, and also given vector v with component a, comma b, comma c is parallel to this line. So to find the equation of this line, the idea is pick another arbitrary point q in the line. Then 2 points determines a vector. So find a vector pq. We find the vector pq by using the formula tip minus tail. So x minus x0, comma y minus y0, comma z minus z0. Then this pq vector is parallel to vector v. Then we know, let's go to this side, pq vector is parallel to v vector if and only if pq vector equals to the constant times the v vectors for some t in R. I hope it makes sense to you all. And two vectors are parallel if one vector equals to constant times the other vectors. So then pq vectors components are x minus x0, y minus y0, z minus z0 equals to, we can multiply this t to each of this component of v vector. So at, comma bt, comma ct. In the next step, also we know two vectors are equal if and only if their corresponding component are equal. So we have x minus x0 equals to at. So x equals to, bring x0 to the right side, x0 plus at. Similarly, y equals to y0 plus bt, z equals to z0 plus ct. And these are the parametric equations of the line. Now in vector form, we can write this x, y, z in component wise for a arbitrary vector x, and then x0 plus at, the x component, y0 plus bt, y component, z0 plus ct, z component. Or simply, we can rewrite this last expression in this way: vector x equals to vector x0 plus t times vector v. So here x vector is the position vector of q, x0 vector is the position vector of p, and then this t is this constant here, and v vector is the given vector which is parallel to the line. I hope this makes sense to you all. Similarly, in the symmetric form of the equation of line, we simply solve t in parametric equations. So let's isolate t first. Here we can take x0 to the left side and divide by a. Then we have x minus x0 over a equals to t. In the second one, here y minus y0 over b equals to t. In the third equation here, z minus z0 over c equals to t. Then to eliminate that t, we have x minus x0 over a equals to y minus y0 over b equals to z minus z0 over c. This is the symmetric equation of line. Great. I hope this makes sense to you all. So let me summarize. To find the equation of a line, we do need two informations. We do need one point and one parallel vector to the line. And we have three forms of equation of line: in parametric form, in vector form, and in symmetric form. Great. So now quick side note. Neither parametric, vector, nor symmetric form of equations of a line is unique. Lines in space arise in two ways: by given 2 points or by given two intersecting planes. Plane intersects in a line. In fact, the equation of line, this is the symmetric form, is the intersection of two planes given below. C. Two straight lines in the space can be either parallel, intersecting, or askew. D. The vector equation of the finite line segment joining 2 points whose position vectors are respectively r0 and r1 is given by r equals to 1 minus t times vector r0 plus t times vector r1, where t lies between 0 and 1. Next, in 2D, y equals to mx plus b represents a line, whereas in 3D it represents a plane, and we have not covered the plane yet. To find the equation of a plane, we do need again two informations. We do need one a point and one the perpendicular vector to the plane. So now let's look on this diagram. This is the plane. We know a point in the plane, and we have given this normal vector n whose components are a, b, and c. Then to find the equation of this plane, let's pick an arbitrary point q in the plane, join pq. Then this 2 point gives us a vector pq. We can find this pq vector by using the formula tip minus tail, so which is x minus x0, y minus y0, z minus z0. Since this pq vector lies in the plane, so it is normal to these normal vectors. Then we can use the orthogonality property between these two vectors. Now let's go to the left side here. Since pq vector is orthogonal to n vector, we know the two vectors are orthogonal if and only if their dot product is 0. Then we know the pq vectors has component x minus x0, y minus y0, z minus z0, and dot with this is the n vectors component a, b, c. We know to take a dot product, we multiply the corresponding component of vectors and add them. So here a times x minus x0 plus b times y minus y0 plus c times z minus z0 equals to 0. Then after simplifying, this is FOIL it and rearrange the term. This gives us ax plus by plus cz equals to d, where d is this number, negative of ax0 plus by0 plus cz0. I hope this makes sense to you all, and this is the standard equation of a plane. Quick note, now how to decode this equation of our plane. So ax plus by plus cz plus d equals to 0 describes a plane in the space with a normal vector, n equals to the coefficient of x, comma coefficient of y, comma coefficient of z, and it passes through a point P, whose position vector is P, that satisfies this equations, and that P equals to minus D. I hope this makes sense to you all. Now let's move on. Plane through 3 points. Here is the idea. We know to find the equation of plane we do need two informations. One is a point and one is a perpendicular vector to the plane. So also we know 3 points determines a 2 vectors where one point is common vertex. Then pick any point out of these 3 points and find the 2 vectors with 1 point common tail and cross these 2 vectors, and that means the cross product of those 2 vectors is the normal vector to the plane. We use that normal vector to find the equation of our plane. So that's the idea. I hope this makes sense to you all. Another note, 2 planes are parallel if their corresponding normal vectors are same. Angle between plane is the angle between their corresponding normal vectors. Great. So now let's move on. There is a side, the vector equation of plane. This is just the extra here. You just pause the video and go over this here. But let me skip here. So next, let's talk about finding the equation of 3 useful coordinate planes. One is xy plane, yz plane, and xz plane. So let me derive the equation of the first, and then I would like you to derive the equation of these other 2 equations of the plane. So let's find the equation of xy plane. So to find the equation of the plane, we do need again 2 informations. One is a point and one is a orthogonal vector. So for xy plane, we pick a point, a easier point to work with. So just pick z coordinate is 0, then our point is 1, 1, 0, and normal vector is simply the n vector, which is the k vector, which is the vector along the z-axis, which is perpendicular to the xy plane. Then the equation of xy plane is by vector equations, n dot x equals to n dot p, where n is given, x is whose component are x, y, z, and p is the position vector of this given point. Then simplifying, this gives us z equals to 0. And yes, the equation of xy plane is z equals to 0. Similarly, it turns out to be the equation of yz plane is x equals to 0, and equation of xz plane is y equals to 0. Awesome. I hope this makes sense to you all. Now let's move on. Next, let's talk about distance. Finding the distance from a point to a line and from a point to a plane. So first, distance between a point, given point is P, whose coordinates are x0, y0, z0, and a line L. This is the line L. So the idea is, let B be the directions vector of the line. The line has a direction vector. Then for any arbitrary point Q on the line, we have the following. So here in this triangle here, this is the distance. This distance is simply the magnitude of QP times sine of theta. So this is simply magnitude of QP times sine theta. And the next step, let's divide by this direction vector, vector V over vector V. Then the numerator is simply nothing, simply the magnitude of the cross product QP cross V over V as it is. Now this is the distance. So the distance equals to QP vector cross with vector v and take the magnitude and divide by magnitude of v. Similarly, let's talk about a distance between a point and a plane. So again, given point on the space is here, P point, whose coordinates are x0, y0, z0, and our plane is down here. And we want to find out this distance from the point to the plane. And when you have a plane, then we have this normal vector, the n vectors. Then this distance, now we can find this distance here. That means we find this height, which is simply nothing. This is simply the scalar projection of this vector onto n. That's the idea. So pick an arbitrary point Q in the plane, join QP. Again, we know 2 point determines a vector by using formula tip minus the tail, and then this QP vectors scalar projections onto n is the height we are looking for. So distance between P and the plane is simply the scalar projection of QP onto n. This is nothing, simply the dot product QP dot n over magnitude of n. Then after simplifying, this gives us this form here. So distance equals to the magnitude of ax0 plus by0 plus cz0 plus a d over under the radical a square plus b square plus c square. And keep in mind, this d is on the plane. We pick our d on the left side. If we have this d on our right side, then we have to bring this right side d to the left side. Then we have a minus sign there. Then we have minus sign here. I hope this makes sense to you all. So now let's move on. One quick remark. Angle between two planes is the angle between their corresponding normal vector. So now with this theory concept, let's do some example. So first example, suppose given 3 points are P, Q and R in the space, then answer the following sub-questions from A through D. Part A, find the equation of the line through P and is parallel to given vector V, whose components are -1, 2, -3. Solutions in vector form. This is the formula. Vector x equals to vector x0 plus t times vector v, where x is the vector, that's the position vector of arbitrary point. X0 vector is the position vector of given point, and vector v is given to us. T is some scalar. T belongs to R. Then this equals to xyz equals to, then the point is here P, so 1 minus t, comma, minus 5 plus 2t, and 6 minus 3t. We're done. So short and sweet. Now, in parametric form, simply write this one in here. X equals to 1 minus t, y equals to minus 5 plus 2t, and z equals to 6 minus 3t. We're done. Similarly, in symmetric form, just from parametric form, solve for t. So then this gives us x minus 1 over minus 1. It's not t, this is minus 1. And y plus 5 over 2 equals to z minus 6 over minus 3. You're done. So it's a typo here. It should be minus 1. It should be minus 1. Let's move on. Similarly, part B, find the equation of the plane through P. N is a perpendicular vector. The given perpendicular vector to the plane is n, whose components are 4, minus 2, 1. Solutions. in vector form, this is the formula, n dot x equals to n dot p. So n vector is 4 minus 2 comma 1, x vector is simply x, y, z, and again n vector is given here, and p vector is the position vector of given point, which is 1 comma minus 5 comma 6, and we take a dot product. When you take a dot product, we multiply the corresponding component and add them. So we have 4x minus 2y plus z equals to, this is 4 times 1 minus 2 times minus 5, 1 times 6. I'll add these product. This gives us 20. I hope this makes sense to you all. Now let's move on. Part C. Find the equation of the line through 2 points P and Q. So let me remind you, to find the equation of a line, we do need two informations, one a point and one a parallel vector to the line. So solutions, so which I wrote here also, need a point and a parallel vector. So pick a point P, and the 2 point determines the vectors. That PQ vector is the vector we are looking for. So PQ equals to tip minus tail. So then 3 minus 1 comma 1 minus minus 5 comma 4 minus 6. So that's a PQ vector, which is 2 comma 6 comma minus 2. Then just apply the formula in vector form. The formula is vector x equals to vector x0 plus t times vector v. That means here x, y, z equals to 1 plus 2t minus 5 plus 6t, 6 minus 2t. Great. Now let's move on. Now in part D, find the equation of the plane through 3 points P, Q, R. Let's begin the solutions. So to find the equation of the plane, again we do need two informations. One is a point and one is a perpendicular vector to the plane. So now here let's pick a point P, and now to get the perpendicular vector, first find two vectors lying on the plane and cross them. Then that cross product will be the normal vector we are looking for. So then n equals to vector PQ cross PR. So PQ vector turns out to be 2 comma 6 comma minus 2. That's the vector we found here. And for PR vector, use tip minus the tail formula again. So PR. So PR vector is 1 minus 1 0, 2 minus minus 5 plus 7, minus 3 minus 6 minus 9. So 0, 7 minus 9. 0, 7 minus 9. Then take the cross product of these two vectors. We know we take a cross product using 3 by 3 determinant. So write in the determinant, first row I, j, k, second row the component of PQ, third row component of PR, and expand that 3 by 3 determinant. Finally, it turns out to be this vector, negative 40, comma 18, comma 14. Hence, the equation of a plane in vector form through these 3 points turns out to be, by formula, n dot x equals to n dot p. N vector is here. X vector is simply x comma y comma z equals to n vector, and this is the position vector of point P. Then after taking this dot product and simplifying, and again keep in mind, when you're taking dot product, we multiply the corresponding component and add them. It turns out to be 20x minus 9y minus 7z equals to 23. I hope this computation makes sense to you all. Now let's move on. Let's do example 2. Determine whether the given two lines L1 and L2, this is the equation of line L1, this is the equation of line L2 are parallel, intersecting, or skew. Now let's begin the solutions. If we have a line, then we can easily find a parallel vector to the line. So the corresponding parallel vector to the first line is, I assume u equals to 2, then 1 and 4, and this is for L1. And for L2, I assume vector v, which is 1, that means coefficient of s, then comma 3 comma minus 1. And by here, obviously u is not parallel to v because they are not scalar multiple to each other. Next, to show intersecting, if they intersect, then we should be able to find one value of t and s such that these are equal, such that x values are equal, y values are equal, z values are equal. So let's find the common intersecting point t and s. But solving first two equations, solve these two equations gives t equals to 8 over 5 and s equals to 11 over 5. And by the way, we can easily solve this equation here. 2t equals to 1 plus s, 2 unknowns. 3 plus t equals to minus 2 plus 3s, 2 are unknown. 2 equations we can easily solve. So we have t value and s value. And these values do not satisfy our third equation here. So consequently, L1 and L2 do not intersect. So that means these two lines must be skew lines. I hope this makes sense to you all. Now let's move on. Example 3. Suppose two planes, P1 with these equations, P2 with these equations are given to us. Then answer the questions A and B. First part, find an angle between two planes. We know the angle between two planes is the angle between their corresponding normal vector. So the corresponding normal vector are, first plane is n1, which is 1, 2, 3, just the coefficient of x, coefficient of y, coefficient of z. That's how we extract the normal vector. Similarly, n2, the normal vector to the second plane, which is 1, minus 1, 1. Hence, by formula, if the angle between these two planes is theta, that means if the angle between these two normal vectors is theta, then we have the formula, the cosine theta equals to n1 dot n2 over magnitude of n1 times magnitude of n2. So here's n1 dot n2, just take the dot product here. So we multiply the corresponding component and add them. 1 times 1 plus 2 times minus 1 minus 2 plus 3 times 1, 3. It turns out to be 2 over magnitude of n1. So under the radical, 1 is square plus 2 is square plus 3 is square. Radical 14. And magnitude of n2 is under the radical, 1 is square plus minus 1 is square plus 1 is square. Turns out to be radical 3. So then simplify. So this is 2 over radical 42. So that means theta equals to cosine inverse 2 over radical 42. Great. I hope this computation makes sense to you all. Now in the part B, find the line of intersection of two planes. So let's find the intersection of two planes. So so one plane is this plane, another plane is this plane. They intersected this line, and the intersection point is P. So to find the equation of line, we do need two informations. One is a point, so let's find the intersecting point and vectors. There are two ways. Let's say one is the vector ways. We find an intersecting point and a parallel vector. So first, for the point, put z equals to 0 and solve these two equations of the plane, then this gives a point, which is this point, which coordinates are 1, 0, 0. And next, for the parallel vector, we have the normal vector of one plane, we have the normal vector of another plane, then we cross them, and that vector is or will be the parallel to this line, and we'll take that vector. So B vector, which is parallel to the line, is simply n1 cross n2. The n1 vectors cross n2, this gives us this vector, which is 5, 2, -3. I hope you can verify this vector, and we know we take a cross product by expanding 3 by 3 determinant. Thus, the equation of line in vector form is, by formula, vector x equals to vector x0 plus t times vector v. So xyz equals to 1 plus 5t, 0 plus 2t, 0 minus 3t. We're done. Let's do alternative way. Another way is algebraic ways. Set one variable equals to a parameter. Say that z variable is a lucky variable to get that parameter t. Then solve other variables in terms of t. So solving for x and y. So here is we put z equals to t. Then we have x plus 2y plus 3t equals to 1. And we have x minus y plus t equals to 1. Then we can easily solve two equations for x and y. Let's see here. So solve for x and y. So we have x plus 2y plus 3t equals to 1. X minus y plus t equals to 1. Then solve x and y in terms of t. We get x equals to 3 minus 5t over 3. And it turns out to be y equals to minus 2t over 3. Hence, the equation of line in parametric form is x equals to that t terms here, 3 minus 5t over 3, y equals to minus 2t over 3, and z equals to that t. We found the equation of line in parametric form. You may be wondering here why we have two different equations of the same line, because the equation of line in vector form, in parametric form, in symmetric form is not unique. Awesome. So let's move on. Part C. Find the distance of the plane from the point. Here is a given point. Here is a given plane. Just apply the formula. By formula, this is the formula. Here the x0. Here this is y0. This is z0. And the d, bring this 1 to the left side. So d equals to minus 1. Then by this formula, it turns out to be 8 over radical 14. Awesome. Let's move on. Example 4, the last example for these sections. So, are these planes, these two planes, parallel? If so, find the distance between them. So, to find the distance between two parallel planes, we need to find out a point in one plane and use this idea to find the distance from that point to the another plane using this formula. So solutions, corresponding normal vectors are, here is a n1 equals to 4, negative 12, 8, and n2 is 3, negative 9, 6, and find their cross product, which is 0. So that means n1 vector is parallel to n2 vector. That means corresponding planes are parallel. So we showed these two vectors are parallel. Or we can use alternate idea also. One vector equals to constant times the other vectors. So next, now take a point in the first plane. So any point. So here let's say we put y and z 0. That means x equals to 5 over 4. So 5 fourth, 0, 0. That's any point in the first plane. Then find the distance from this point to the another plane. Hence, by formula, distance from point P to another plane is, by this formula, the absolute value of ax0 plus by0 plus cg0 plus d over under the radical a square plus b square plus c square. So here a is using this second plane, so 3, x0 is 5/4, and b is -9, then y0 is 0, plus c is 6, and z0 is 0, and d, you need to bring this 1 to the left side, then d is -1 over under the radical 3 is square plus this -9 is square plus this 6 is square. And after simplifying, it turns out to be 11 over 12 times radical 14. This is the distance between these two planes. So I hope this makes sense to you all. So we finish these sections. Thank you.